Hello, reality deniers and flat earth debunkers. Today, we're going to have a look at some long-distance photography and see whether there is any evidence for a curve. So let's dive right in and head straight down to where I took the photos in sunny New Plymouth. Here we are on Mount Motoroa, just above Port Taranaki in New Plymouth, New Zealand, and we are looking to our northeast. Let's zoom in a little. In this photo, we can see right across the northern Taranaki Bight to the coast of the Waikato, up around Waikowau. This area is mostly made up of limestone and sandstone. The famous Waitomo caves are not far inland from the rugged country we can make out in the distance. We can zoom in to get a better look at the area we can see. While at this distance this looks like a single mountain near the shore, we are actually seeing the Harangi Ranges with many peaks and ridges across the larger countryside. On the far left of the image is the main peak in the ranges. This is Mount Whariorino, and the conservation area that encompasses the ranges is named after it. You can make out the peak in the top center of this photo. Looking at the topographical map of the area, you can see how rugged this countryside is. It is covered in thick bush and is known as a popular hunting and tramping destination. Several of the peaks are above 500 meters, with Mount Whariorino being the highest at 649 meters. Now that we have identified what we are looking at across the sea, we can return to New Plymouth, and using Google Maps, we can get a distance between Mount Motoroa and Mount Whariorino. Using the distance function, we find out that the straight line distance between the two is 92 kilometers, 420 meters, or 57.43 miles for those of you not caught up with the metric system yet. We now move to the second location, which is much closer to sea level. We head slightly to our east and downhill to the Lee Breakwater car park, where the next set of photos were taken on the same day. While the Google Street View image was taken on a day when clouds obstruct our view, we can switch over to 3D mode and not only see what should be visible, but also get our distance from the Lee Breakwater car park to Mount Whariorino. We are a little closer here, with the distance being just 90 kilometers and 780 meters, or 56.41 miles. Looking at the photos taken, we can again make out the distinctive shape of Mount Whariorino across the sea of the northern Taranaki Bight. Zooming in, we can see the shape and sizes of the ranges and mountains remain unchanged, at least for the parts we can see. This shows that perspective is not at play here, as that would have made the ranges shorter in both height and length. We can spin around in Google Maps, looking back towards the port and both Mount Motoroa and Mount Paratutu. Switching over to the photo I took, you can see where the first set of photos was taken on Mount Motoroa. This map shows both photo locations as red dots and also gives their altitudes, 81 meters for Mount Motoroa and 1 meter for the Lee Breakwater car park. I added another meter to get the camera altitude based on my taking the images at around chest height. I used Google Maps to show the lines of direction between the two photo location sites and Mount Whariorino. And here we have the view of both lines of direction from the sites to the mountain, taken from above. This shows the full distance across the sea from New Plymouth to the Harangi Ranges. Switching over to Walter Bislin's advanced Earth curvature calculator, we can now determine what we should see based on the two locations and the distances to the Harangi Ranges and Mount Whariorino. We will deal with Mount Motoroa first, and so we need to enter the information for the location. We can put in the altitude as 82 meters and the distance to our target as 92,420. Finally, our target height is 649 meters. Oh, and we need to add in standard atmospheric refraction, as this has an effect. Now we can check out the results. The most important thing to look at here is that only around 211 meters will be hidden according to the calculator. Later, we will be looking at this, so keep that number in mind. Right, now we can do the same thing for the Lee Breakwater car park. First, we will change the camera altitude to 2 meters. Next, we can change the target distance to 90 kilometers and 780 meters. We don't need to change our target height, and refraction is already set. With the information in, we can look at the results, and here we find that at the Breakwater car park, over 472 meters of the ranges are going to be hidden from view. That is a huge amount more than what was calculated for Mount Motoroa. So what does all of this mean? For this, we need to go back to the topographical map we had earlier and keep in mind the two numbers that show how much should be hidden from view. When we look at our topographic map, we are given lines of altitude and peaks, allowing us to determine what we should see from each location. As we look at the map, we can see that while several peaks and areas around Mount Faria-Reno are over 470 meters in height, much of the area south of it is in the 250 to 390 range. While this is over the 211 meters estimated to be hidden when viewed from Mount Motoroa, it is well below the 470 meters estimated to be hidden when viewed from the Lee Breakwater car park. The same is true when we look north on the map, an area with ridges and peaks above 470 meters, but most of the ranges north are less than 300 meters in height. This is enough to be seen from Mount Motoroa, but not the Lee Breakwater car park. So what does all of this mean, and how do we determine if there really is a curve? If there is a curve and estimates by Walter Bislin's Earth Curve Calculator are correct, then when we are on Mount Motoroa, we should be able to see most of the Harangi ranges in a single connected line, whereas when we are at the Lee Breakwater, despite being closer, the area around Mount Faria-Reno should be visible, but not the ranges to the north or south. This should make the highest part of the ranges appear to be an island with the horizon hiding the lower area. To answer this, we need to find out what we actually see. If you have enjoyed my content and possibly learned something new, then please throw me a like and share this with your friends and enemies. On that note, and with the globe once more standing up to scrutiny, I bid you all a fond farewell. Goodbye.